just the function of layer change on exposure to any solvent. For example, if you have a drilling mud and you kind of add any additive into it, and you just want to see if this additive would change its properties or not, or if it has interacted with the clay or not, you will observe its dspacing. So dspacing in terms of clay minerals is termed as d-basal or D001. So you don't need to confuse dspacing and interlayer spacing, because these are two different things. So interlayer spacing is just the spacing between two clay layers, while this colorful particular clay layer for montmorillonite is aluminosilicate layer, and these blue dots are the cations present between aluminosilicate layers, where d-spacing is the combination of interlayer space and clay layer. So if there is a change in d-spacing, so it means your additive has worked. So now just let's cut the chase and talk about a very important software, Xpert Highscore. You're not gonna find this software on internet. Mostly lab technicians would prefer for you to come to the lab and just use the software on the spot, because they won't give you the software either. So you can get the files in number of formats, but you do not need to worry if the format is not XRD ML, the format that I am going to use, because this is a very versatile software and it can pick kind of any format you want. For example, right now I have a drilling mud sample, a wet drilling mud sample, and I'm just going to run the file, and this is how an XRD plot of that particular drilling mud will look like. So you don't have to do anything, just three simple basic steps to do the curve fitting, because these 2 theta values and this intensity values is the graph, and 2 theta values are independent. It means these are the 2 theta values that we provide, and in terms of dependent values we get the counts or intensity values. But the thing that we need to use the software for is that we have to do the curve fitting. We need to do the curve fitting to find the exact value of 2 thetas that is corresponding to the type of minerals that we want to find out or identify. So for that, just do the determine background. This is just to see if our baseline is actually on the base, and it is not kind of overlapping any kind of peak. So I think it's the best arrangement, because if I play with it with the granularity, you will see the baseline will start moving upward and low. So I think this particular arrangement 26, it seems fine to me, so I can just kind of accept this. Second thing you need to do, you just need to find peaks. So you will see, just search peaks, and you will see the software has assigned and found and assigned the peaks. Just click accept, but we just cannot rely on the software. We need to do our checking on our part on as well. So just zoom it just to see if the software has done the right analysis. So you will see every peak has been assigned one dash or one line. So if you find a peak, that there is a peak in your sample but the software hasn't detected it, for example this one, so what you can do, you can just click and insert peak, just click over there, and now the software has read that peak as well, because that was obviously a peak. Now you can just simply zoom out. So firstly, determine background, secondly you will search peaks, and the third easy steps you will do search match. So this will just search the match, the type of minerals that are corresponding to your fitted curves. So you see it has kind of identified silica and quartz differently, because this particular software is prone to crystallography. Quartz is the crystallic form of silica, while silica is just an amorphous form, but we know we both have SiO2 in our clay sample, because your clay has huge amount of SiO2, and after SiO2 I am looking for alumina. I also have alumina. I also have this quartz. What else? I have hematite as well, Fe2O3. I have calcite as well in my sample. I don't have sucrose, I don't have uranium oxide, boronite, chromium or anything in it. So this would be it. So if your software has run properly but sometimes it causes a problem, so this particular quantification tab doesn't work. So if it is working, probably you will get a pie chart over here which will give you a quantitative analysis or relative percentage of all the minerals present in it. Or otherwise you can label peaks by the type of chemical or minerals present in it. So this way every peak is assigned to a particular mineral that your sample would have. Now the most important thing, how can you find the d-spacing? For that you just need to use Excel. For example, in this file you can see the data that the XRD technician would give you will be in the form of 2 theta angle and intensity. So right now I have combined all the files. This is my blank sample and these are the percentages of the additive that I have added. This is basically 2 theta is constant for all samples, while these are the intensity values that is being changed. So the most important thing, if you want to report your results in literature or your thesis, you want to do that in just one graph, and for that the stacking comes in practice. So now if I just draw the graph simply, they will overlap with each other and there won't be really much readable. So what I do, I kind of add a particular I shift in all the respective ones. For example, in I 0.1 values I have added this 5000, and for 0.5 I have added this 10,000. So everything would remain same, and now by doing this you will get a graph that has proper presentation just like this with a proper stacking. Every peak is corresponding to a particular 2 theta values. So now you may see there are a lot of peaks, but the d-spacing value for one sample would be just 1, and that would correspond to your major peak. That is the peak that is most vibrant in your whole fingerprint. So just use that 2 theta range in which your vibrant peak is coming, and every peak refers to 1 2 theta values, and from that you can just find 2 theta values, from divided by 2 you get theta values, convert into radians, find sine theta. Now use Bragg's equation, Bragg's law to find the value of d-spacing. Now if you can see, for blank sample I have the d-spacing of 18 armstones, but by adding my additive into it, the d-spacing for wet sample will change. So it means the additive had expelled water from the layers and it has taken place. It has successfully intercalculated in the interlayer spacing. So that's how we can kind of conclude that the additive has successfully intercalated in the interlayer spacing of your mud, and your mud, the properties of mud has changed, and the additive has changed the rheological as well as the drilling fluid properties of your mud. So that would be it for today's video. I'll be back with one more video. So till then,